All right, girls, so this is going to be our Unit 4. Unit 4 is on XYR, and I'll write that out for you. It's going to be on XYR, and everybody's favorite, the unit circle, okay? Today we're just going to focus on XYR. That's what the first quiz will be on, and you can use a calculator for XYR. We are not using a calculator for the unit circle, okay? So this is going to be a split unit with our calculator, no calculator usage. And if you can, go ahead and write down some notes for me so we can go ahead and get a head start in our vocabulary for this unit. So we should be familiar with the 6 trig functions: sine, cosine, secant, tangent, cotangent, but let's go ahead and copy this down. And they're related because they are reciprocals. So sine's reciprocal is 1 over cosecant, or it's equivalent to 1 over cosecant because they're reciprocals. Cosine is 1 over secant. Tangent is 1 over cotangent. I believe we talked about that in Unit 1, if I'm remembering that correctly. But go ahead, jot it down. It's always good to have it as a reference in your notes. Okay, and then what we're focusing on today are XYR. What does that mean? So we're going to determine the 6 trigonometric functions of an angle theta given a coordinate point that the terminal ray actually passes through. So if you see right here, we have this angle theta, and if I want to figure out the sine of theta, okay, we know sine is opposite, I put a theta, as opposite over hypotenuse, but what if we were in the coordinate plane? What if that terminal ray passes through a coordinate point xy? Well, we actually call the hypotenuse r. That's going to stand for the radius once we get to a unit circle. And then we're actually going to use our y value and our x value for the sides of the triangle, okay? Because we're in the xy plane. So instead of the sine of theta, if I'm looking at theta right here, what's opposite of theta? It's y. So instead of opposite, we can use y. And what's the hypotenuse? Like I said earlier, the hypotenuse we represent with the letter R right here. So instead of hypotenuse, we'll put an R. So for sine theta, if we're in the coordinate plane, instead of opposite over hypotenuse, we will use y over r. Well, then cosecant, its reciprocal would be r over y. Now let's look at cosine. Cosine of theta, yes, we know that is adjacent over hypotenuse. But let's see what it would be right here. So what's adjacent to theta? Well, adjacent to theta would be x. The hypotenuse is still r, so cosine theta, instead of adjacent over hypotenuse, we're going to use x over r. And then its reciprocal secant would be r over x. Okay, and I do have the formal definitions for you right here. So you can go ahead and write these 6 trig functions. And the only thing else I need you to write, I don't need you to write where the denominators do not need to be 0, but let's go ahead and add r is always positive. R is always positive because to find r, you have to find the square root of x squared plus y squared, a Pythagorean theorem essentially, because we're in right triangles again. And because of that, you can't take the square root, and because we're finding that distance, just let r always be positive. And your negatives or your positives will be decided which quadrant you are in. Okay, so here's example 1. Let's go ahead and do 2 examples together. Yeah, let's just do 2 examples together, and then that'll be it for this video. That'll be a good intro. Okay, example 1. Find the 6 values of the 6 trigonometric... Whoa, oh my gosh, I can't talk. The terminal side of an angle theta passes through the point 815. Okay, so we are in quadrant 1 because that's positive, positive, right? So for our quadrants, we do have to know our signs. Like quadrant 1 is positive, positive. This is negative, positive. And negative, negative for quadrant 3. Positive, negative for quadrant 4. Now here, we're going to use our x, y, r definition. So for this coordinate point, 815, I know x is 8, y is 15, r I would have to solve for, excuse me, by using the Pythagorean theorem. And again, I'm going to draw this out for you so you see what's happening. So I have an angle whose terminal ray is in quadrant 1 and passes through the point 815. And I'm finding all 6 trig functions for that angle theta. And to figure out what r is, because I know x is 8, y is 15, well, how can I solve for r, or how can I solve for the hypotenuse by using the Pythagorean theorem? So I have 8 squared plus 15 squared equals r squared. Of course, I don't have my calculator with me, but I think this is a Pythagorean triple. Let's see. That would be 289. Yep, that's a Pythagorean triple. If I square root that, that's 17. So now that I have x, y, and r, and I know they're all positive, I can go ahead and set up my ratios. So sine of theta, and look, I'm gonna have my definitions up here as y over r, so that would be 15 over 17. Cosecant, its reciprocal, 17 over 15. Okay, cosine of theta would be 8 over 17. Secant, its reciprocal, 17 over 18. Tangent is y over x. Makes a little bit of room. Okay, and our y was 15. X was 8. Cotangent, its reciprocal, would be 8 over 15. All right, and that is example 1. Alrighty, for example 2. Okay, so this time the coordinate point is -3, -4, so I am in quadrant 3. You don't have to draw this out, I'm just showing you what's going on here at this point. So I know, given that coordinate point, that x is -3, y is -4. That is a Pythagorean triple, so if you know that's 5 for the hypotenuse, awesome, you don't have to solve. Or if you need to use the Pythagorean theorem to solve for the hypotenuse, that's fine. Oops. Then I have 9 plus 16 equals r squared, 25. So 5 equals r, okay? X was -3, y was -4, and now I can find all 6 trig functions. Sine of theta is y over r, so that's -4/5. Oh, not cosine, I wanted to do its reciprocal. Cosecant would be -5/4. Cosine of theta would be x, -3/5. secant of theta, negative 5/3. Its reciprocal, or r over x. And then we have tangent is y over x. Be careful here. So yes, it would be negative 4 over negative 3. However, that reduces to a positive. So that's 4/3. And we have cotangent, its reciprocal, well, same idea. A negative over a positive is going to reduce to a negative over a negative will reduce to a positive. All right, ladies, so that is a good starting point with XYR. We will step it up a little bit when I see you next and practice.